right, let's pick up with this one. All right, so let W equal x to the 1/4. W squared equals x to the 1/4 squared. If excuse me, x to the 1/4 squared. Right? If you multiply 1/4 times 2, right, that's 1/2. So W squared equals x to the 1/2. All right, so now we've got W squared minus 5W plus 6 equals 0. Multiplies to give us 6, adds to give us -5. That's going to be 3 and 2. So W minus 3 times W minus 2. Got to substitute back. This is much nicer having one problem per page. Right? And so that's x to the 1/4 minus 3, x to the 1/4 minus 2 equals 0. All right, so now let's solve. X to the 1/4 minus 3 equals 0. X to the 1/4 equals 3. Raise both sides to the 4th power. All right, so that's going to be x equals 81. Right? If you raise to an even power, right, it can give us some false solutions. So we got to check it back. All right, so but if we plug it back in, the 4th root, oops, that's just weird. The 4th root of 81 minus 3 would equal, so we want to know, does that equal 0? Right, well, the 4th root of 81 is 3, and yes, 3 minus 3 equals 0. So that checks out. That's good. So this is a solution. Right, and then x to the 1/4 minus 2 equals 0, which is x to the 1/4 equals 2. Raise both sides to the 4th power. So x equals 16. Let's plug that back in. So we have 4th root of 16 minus 2 equals 0. 4th root of 16 is 2. And that checks out as well, so that is a good solution. All right, so this one has 2 solutions as well. Right, we had a couple. We've had second one with 2 solutions. Second one, third one, I don't remember. But the other one was in the other video. All right, what do you think this one might be? Could it be substitution? Let's first rewrite it. Move the 3 over. So we have x to the 1/3 plus 2x to the 1/6 minus 3 equals 0. Right? And then if you've got, so 1/6 times 2, 1/3. Right? So substitution will work here. All right, so let W equal x to the 1/6. W squared is x to the 1/6 squared. When you raise power to a power, you multiply. 1/6 times 2 would be 2/6, which is the same as 1/3. So W squared is x to the 1/3. All right, so now we'll just replace the x to the 1/3 with the W squared. Replace x to the 1/6 with a W. 1 times -3 equals -3. Multiplies to give you -3, adds to give you 2, would be 3 and -1. So W plus 3 and W minus 1. Substitute back. And so we have x to the 1/6 plus 3 times x to the 1/6 minus 1 equals 0. All right, and now we'll solve. X minus 1/6 plus 3 equals 0. X to the 1/6 equals -3. let's raise both those to the 6th power to isolate x. So now we have x equals, and 3 to the 6th power is 729, positive 729. All right, so now let's check that one out. So the 6th root of 729 plus 3 is supposed to equal 0. Well, the 6th root of 729 is 3, and 3 plus 3 does not equal 0. So 6 is not 0. So this is a no. No, that one is not a solution. Let's try the other one. All right, so x to the 1, 6 minus 1 equals 0. X to the 1, 6 equals 1. Let's raise both of those to the 6th power. So x equals 1, and the 6th root of 1 minus 1 equals 0. Well, any root of 1 is 1, and 1 minus 1 does equal 0. So this one checks out, and that's a good solution. So just one solution here. So you can get false solutions when you raise to an even power, because the even power makes everything positive. All right. They're a little different one, but we can still use substitution, right? Right? Because this is to the 1st power, and this is same thing, but squared, right? So let's just use substitution. And why? Because it's nicer to look at. Use substitution. So let w equal 3 minus x to the 1/2 power. That means w squared is 3 minus x to the 1/2 power squared. Right? So no matter how ugly it looks like inside the parenthesis, no matter how ugly it is, if one is just the other squared, go ahead and use substitution. That gives us w squared minus 10w plus 21 equals 0. Well, doesn't that look just so much easier? You look at the first one, you're like, oh, how do I factor it? You look at the second one, you're like, oh, well, that's really easy. Multiplies, 1 times 21 is 21. Multiplies to give us 21. Adds to give us negative 10. W minus 7 and w minus 3. All right, let's substitute back. So we have w minus 7 equal, oh, excuse me, substitute back. So we have 3 minus x to the 1/2 minus 7 times 3 minus x to the 1/2 minus 3. Now, because this is what w is. That's just w equals 0. Well, we should simplify that. Right? So we have 3 minus 7, that's negative 4. So we have negative x to the 1/2 minus 4. And 3 minus 3 is 0. So negative x to the 1/2 equals 0. All right, so let's set our factors equal to 0. All right, so we have negative x to the 1/2 minus 4 equals 0. And negative x to the 1/2 equals 0. All right, so let's just do the second one first. If I divide both sides by negative 1, 0 divided by negative 1 is 0. And if I raise 0 to any power, it's still 0. And if you multiply anything by 0, it's 0. So this is clearly a good solution. Let's go over to the other one. All right, so negative x to the 1/2 minus 4 equals 0. Let's add 4 to both sides. Negative x to the 1/2 equals 4. Let's divide both sides by negative 1. X to the 1/2 equals negative 4. And let's square both sides. All right, and if we square both sides, we've got x equals 16. And if we plug that back in, I have negative square root of 16 minus 4 equals 0. Right? Well, that would be negative 4 minus 4 equals 0. Since when negative 8 does not equal 0. So not x, this is no, not a solution. So 0 was the only solution here. So if that's 0, it works out. Otherwise, not so much. And by the way, you can plug, let's plug it back into the original. There's just the 0, obviously not the 4 or 16. Let's plug it back into the original and just check that out. So 3 minus square root of 0 squared minus 10 times 3 minus square root of 0 plus 21 equals 0. All right, so this is 3 squared minus, well, that's going to be 10 times 3 plus 21 equals 0. So that's 9 minus 30 plus 21 equals 0. Well, 9 minus 30 is negative 21. Negative 21 plus 21 is 0. So you can see when I plug it back into the original, it does check out. Right? We won't check the other one, 16, because it didn't work in the factored version. It's not going to work when we plug it back in to the original. All right, factor by grouping rational exponents. All right, so I'm going to write this over here. You can only factor out the smallest exponent either term has. All right, so 1/2 and 5/2, which is smaller? 1/2, right? 1/2 is smaller than 5/2. So all I can factor out is 1/2. All right? So we're going to factor out x to the 1/2. Sometimes students have difficulty with these just because they're fractions. But remember, when you divide, you subtract exponents, right? If I had something simple like x to the 4th, here, let me get x to the 5th. X to the 5th divided by x cubed, that's the same as x to the 5 minus 3 power, or x squared, right? So you subtract exponents to divide. I'm going to erase that because I need a space, but I am going to write this. You subtract exponents to divide. I am going to write the subtraction here just because these are notes, and this is a review, and you write however much you need to be able to solve. All right, so we have x to the 1/2 divided by x to the 1/2. So that's x to the 1/2 minus 1/2, right? Because when we divide, we subtract exponents, minus x to the 5/2 minus 1/2. So that's x to the 1/2. 1/2 minus 1/2 is 0. X to the 0 is 1. Actually, maybe I should write that. I'll write x to the 0. we know x to the 0 is 1. Minus 5 halves minus 1 half is 4 halves. Right. Well, that's just 1 minus x squared. There we go. Okay. So I'll write in that, the exact, what we get when we exactly subtract and then simplify, just so it's clear. I don't want to jump too many steps and then you're watching this video and you're, all right, so let's see what we got here. All right, we've got x to the negative 1 half, x to the positive 1 half. Well, which is smaller? Right? Negative 1 half is smaller than 1 half. Maybe I should have left that up over here too. 1 half is smaller than 5 halves. So we can only take out a negative 1 half. That's it. And likewise, we got the same thing going on here. Negative 1 half is smaller than 1 half. So I'll write our greatest common factor. So on the first one, our greatest common factor is x to the 1 half. In the second one, greatest common factor is x, I have to write it down here, because it's 2 terms. X to the negative 1 half times x plus 3 to the negative 1 half. So we have x to the negative 1 half times x plus 3 to the negative 1 half. And then I'm going to run out of space, and if I do, I'm just going to write on below it. All right, so we have x to the negative 1 half minus a negative 1 half, because when we divide, we subtract exponents, times x plus 3 to the 1 half minus negative 1 half. And then I told you I ran out of space, so plus, here's the next term. Make sure I have parentheses here, right? Because this is being pulled out of both of them. All right, so plus x to the 1 half minus negative 1 half times, I got that one, we got the second one, x plus 3 to the negative 1 half minus negative 1 half. And then close our, oops, 2 parentheses there. Close that parentheses and close the whole thing. So sorry I had to write it as 2 lines, but when I write down the subtraction, it took a little too much space. All right, so we have what we pulled out, x to the negative 1 half times x plus 3 to the negative 1 half times, all right, so that's negative 1 half plus 1 half, right, minus a negative. Well, that's 0, and anything to the 0 power is 1, right? So this is just 1, which makes sense, right? X to the negative half divided by x to the negative half would be 1, times negative 1 half minus a negative 1 half is 1 half plus 1 half. 1 half plus 1 half is 1. So that's x plus 3 to the first power. Looking much nicer. Plus, right, so 1 half minus a negative, that's 1 half plus 1 half, so that's x to the first power. I'll even put the 1 there. And then negative 1 half plus 1 half is 0. So times x plus 3 to the 0 power. I'll write x plus 3 to the 0 power. And then this one, by the way, was x to the 0 power. All right, so now let's simplify, and that should have an ending parenthesis there. Let's just simplify that. So x to the negative 1 half, x plus 3 to the negative 1 half, and x to the 0 is 1, so I don't need that coefficient. I don't need an exponent of 1. X plus 3, and then plus x, and anything to the 0 power is 1, and 1 times x is still x. So combine our like terms, x to the negative 1/2 times x plus 3 to the negative 1/2 times 2x plus 3. So now if I were solving this, right, we're setting it equal to 0 to solve for when x is 0 for this equation. In the factored form, it wouldn't be difficult, right? We just set each of our factors equal to 0 now that we've pulled out the greatest common factors. So this is going to be an important skill later on, which is why I'm reviewing it now. We'll do a few more like that one. All right, this one is just a factor by grouping with rational exponents. And actually, so we're just going to pull out a greatest common factor. I don't know if we can do more, but we're definitely going to pull out and I think once we pull out a greatest common factor, we might be able to factor a little bit more. All right, so we've got x to the 3/2, x to the 1/2, x to the negative 1/2. Who's the smallest? X to the negative 1/2. So greatest common factor is x to the negative 1/2. So we have x to the negative 1/2 times x to the 3/2 minus a negative 1/2 plus 8x to the 1/2 minus a negative 1/2, because when we divide terms raised to a power, we subtract exponents, and then plus 15x to the negative 1/2 power minus negative 1/2. All right, so x to the negative 1/2. 3/2 plus 1/2 is going to be x to the 4/2. And if you're doing that in your head, you're like 4/2, that's 2. You can just write x squared. I'm just writing 4/2 because I want to make sure that everyone is okay. 1/2 minus the negative, so it'd be 1/2 plus 1/2. I think we're all going to be okay if we say, well, 1, right? 1/2 plus 1/2, that's 1. And then 1/2, negative 1/2 plus 1/2, that's going to be 15x to the 0 power. Close my parentheses. So that's just x times negative 1/2 times x squared plus 8x plus 15. And yep, we were going to be able to factor that because that's just x plus 5 times x plus 3. And we're done with this one. Let's go on to the next one. By the way, how many more of these I have? We've got 4 screens. All right, let's see how fast we can do. All right, what's the greatest common factor? Who's the smallest? All right, it's going to be x to the negative 3/2. So we have x to the negative 3/2 times 2x to the 1/2 minus a negative 3/2 plus 5x negative 1/2 minus a negative 3/2, and then plus 2x to the negative 3/2 minus a negative 3/2. Close the parentheses. So x to the negative 3/2, I might start skipping a few steps here. 1/2 plus 3/2 is 4/2. Can we all agree that's 2x squared? 1/2, and then plus 5 times 5x to the negative 1/2 plus 3/2 is going to be 2/2, and that's just 1. So 2x squared plus 5x, and then this is this is negative 3/2 plus 3/2, that's 0. Anything to the 0 power is 1, so that's just going to be plus 2. And we can now use factor by grouping to factor this part, right? So 2 times 2 is 4. Two numbers that multiply to give us 4, but add to give us 5 is 4 and 1. So we've got, so I'm just going to do this. I don't have to keep writing that. So we have 2x squared plus 4x, you're a group, plus x plus 2, your group. Factor out a 2x, we got x plus 2. Factor out a 1, we got x plus 2. So now all factored, we have the x to the negative 3 halves times, factor out that repeating x plus 2, times the leftovers 2x plus 1. All right, and if you had to solve that, that's nice and easy, right? If this was set equal to 0, we were finding out when this equals 0, be no problem, right? It'd be 0, negative 2, and negative 1/2. All right, oh, this one's a nice easy one. All right, so who's the smallest? Greatest common factor is, we're factoring out a binomial, right? Is x plus 2. 3 halves is smaller than 7 halves, so x plus 2 to the 3 halves power. So we have x plus 2 to the 3 halves times x plus 2 to the 7 halves minus 3 halves minus x plus 2 to the 3 halves minus 3 halves. All right, so that's x plus 2 to the 3 halves power. 7 halves minus 3 halves is 4 halves, which is 2. So that's going to be x plus 2 squared. Oops, parentheses, right, because they're times, right, are what we factored out. And then x plus 3 halves minus 3 halves, that's 0. Anything to the 0 power is 1, right? Obviously, x plus 2 to the 3 halves divided by x plus 2 to the 3 halves is just going to be 1. All right? We should simplify that out. So x plus 2 to the 3 halves, if we square the x plus 2, because we're going to be able to combine like terms, can't solve that. You know what we could do? Let's use, instead of factoring and instead of multiplying it out, let's use difference of squares. That'd be a lot easier. All right, so then it would be square root x plus 2 plus square root times square root x plus 2 minus square root. So that's going to be x plus 2 to the 3 halves times x plus 3 times x plus 1. There we go. Much easier. Get to use some things from previous videos. All right, so here our greatest common factor is going to be the x plus 1 to the 1/2, because 1/2 is smaller than 3 halves or 5 halves. Right, so we have x plus 1 to the 1/2 times, you got the 4 there, 4 times x plus 1 to the 1/2 minus 1/2 minus 5 times x plus 1 to the 3 halves minus 1/2, and then plus x plus 1 to the 5 halves minus 1/2. Okay. X plus 1 to the 1/2. 1/2 minus 1/2 is 0. Anything to the 0 power is 1. That's just 4. 3 halves minus 1/2 is 2 halves. That's just 1. So times 5 times x plus 1. And then 5 halves minus 1/2 is 4 halves, which is 2. So x plus 1 squared. Let's rewrite the ordering there. And if you notice, we can use substitution to factor this. nice and easy because this is quadratic-like, right? That w equal x plus 1, w squared is x plus 1 squared. So that would give us, I'm just going to do this because that's going to be all by itself until we substitute back. So then this would be w squared minus 5w plus 4. And we just had one just like this before. W minus 4 times w minus 1. Right? Multiplies to give you 4, adds to give you negative 5. And then we got to substitute back. So x plus 1 to the 1/2 times, the w was x plus 1, so x plus 1 minus 4 times x plus 1 minus 1. Well, let's simplify that. So x plus 1 to the 1/2. The x plus 1 minus 1 is x. That really looks better over here, doesn't it? Let's just move this one to the front. All right, he just went to the front. I mean, there's nothing wrong with the x being at the end. He just looks better in the front. And then this would be x minus 3. And we're done. Right? And see, if this was something you were setting equal to 0 to solve, this would be easy, right? Now it's easy. It's going to be 0, it's going to be negative 1, and it's going to be 3. And yeah, we'll do this last one. All right, so 2 last factorings, really quick. You know what? We have done a whole lot of factoring here. And these are very similar to other problems we've already done. All right, we would just use substitution. So I say we're done. Thanks for watching. Bye for now.